Welcome to this exciting presentation that will highlight cutting-edge security architecture and how they can deliver effective protection in the increasingly interconnected and threatening world we live in. Imagine a digital future where our sensitive data is safe, cyber threats are neutralized, and organizations operate with confidence and peace of mind. This future is possible thanks to advanced security architecture that are redefining the way we protect our vital information. During this presentation, we'll explore the latest trend and innovative strategy that are the heart of security architecture. We'll discover how zero trust architecture can protect us through policy-based access and microsegmentation. We will see how the software-defined perimeter can create a virtual perimeter around us, limiting access only to those who are verified. And we will also explore how container security and artificial intelligence are revolutionizing the cybersecurity landscape. Are you ready to dive into the future of cybersecurity? Whether you're a security professional, business executive, or just a curious, this presentation will provide you with an in-depth look at the cutting-edge security architecture and their real-world impacts. Get ready to learn how we can secure our digital future and tackle cyber threat challenges proactively and intelligently. Turn on your minds and get ready for an exciting journey into the world of cybersecurity. In the digital world we live in, the traditional approach based on implicit trust is no longer sufficient to protect organizations from sophisticated cyber threats. Zero trust architecture is based on a fundamental concept: never trust implicitly any user or device on the network. This means that every access request, regardless of its origin or the user location, must be carefully evaluated and authorized based on several factors: the identity of the user, the context of the access, the device used, and other relevant information are taken into account before granting access to network resources. Zero Trust architecture takes a granular approach to policy-based access. This means that only authorized user can access the specific resource needed to perform their task. For example, an entry-level employee will only have access to resources essential to her job, while an administration will have access to higher level of privilege. Additionally, Zero Trust architecture uses microsegmentation to divide the network into smaller segments. This allows you to limit access only to authorized resources within each segment, further reducing the attack surface and the risk of propagation of any breaches. Implementing zero trust architecture requires a combination of technology, processes, and best practices. Some of the key elements include multi-factor authentication to verify user identities, use of encrypted channels to secure communication, and continuous login verification during user session. The benefits of zero trust architecture are numerous. First, it reduces the risk of unauthorized access and data breach. It also improves visibility and control over your network, enabling faster and more targeted response to threats. The main idea of software-defined perimeter is to create a virtual perimeter around each authorized user rather than relying on a traditional network perimeter. This virtual perimeter is defined by the software and can be customized for each user, allowing for more granular control over access to resources. In practice, the software-defined perimeter uses a forget-all or hide-all approach. This means that the resources within the network environment are not visible to unauthorized or unauthenticated users. Only after passing the necessary authentication and authorization will the user have access to the specific resource required. One of the key aspects of a software-defined perimeter is the end-to-end encryption of communications, which means that all communication between the authorized user and the resource are encrypted, ensuring the privacy and security of the information exchanged. The software-defined perimeter approach offers many advantages. First, it reduces the attack surface. As resources are not visible unless the user has passed authentication, it also restricts access to only necessary resources, reducing the risk of unauthorized access or lateral movement within the network. Finally, the software defined provides greater flexibility and scalability, allowing your organization to quickly adapt to new security needs. With the widespread adoption of containers, it has become essential to ensure the security of the container environment. Containers offer many benefits in terms of agility, scalability, and ease of application development and deployment. However, as with any other technology, it's imperative that you implement proper security measures to protect your containerized applications. Container security encompasses a set of practices, technology, and processes that aim to mitigate vulnerability and secure containerized application through their lifecycle, from development to deployment and management. One of the key best practices in container security is the use of secure image. Container images should be checked for vulnerability or RAG component. It's important to scan your images and update them regularly to ensure that they are free from known flaws or vulnerability. In addition to images, it's imperative that you implement an appropriate access and permission policy for containers. This includes assigning appropriate privilege to different users and implementing granular control over access to resources within the containers. Additionally, container security requires continuous monitoring of security metrics and activities. You should collect and analyze container security logs to identify potential anomalies or suspicious behavior. Automation can play an important role in monitoring and responding to real time security events. Finally, container security requires a strong security culture and close collaboration between development, operation, and security team. Artificial intelligence, in particular machine learning, can analyze large amounts of data quickly and efficiently, identifying anomalous patterns and behavior that could indicate the presence of cyber threats. This allows for early detection and rapid response to attacks. Thank you all for taking part in this presentation on cutting-edge security architecture and the latest trends in data protection. I hope it has been an informative and inspiring journey through the innovation that are shaping the future of cybersecurity.